Good evening, and thank you all for joining us today. My name is Rashmita, and I'm the event planner for Microsoft Reactor Bengaluru, India. This session will run over the next 60 minutes, including Q&A. I would now like to welcome Karan and Vivek, our speakers for today's session. Karan leads developer relation for GitHub in India. He works closely with the developer community in helping them get the best out of the GitHub platform. Our next speaker, Vivek, is a tech enthusiast and an open source contributor with around 15 years of experience in the software industry. He works at Microsoft as a senior cloud advocate. But before we start the session, I would request all of you to read our code of conduct. We are all here to learn, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. With this, I'll hand over to Vivek to begin the session. Over to you, Vivek.
Hey, Rasmita, thanks for the introduction. And Karan, welcome to Azure Happy Hour. And I'm hoping this is your first Azure Happy Hour, is it? Okay.
Yes, thanks, Vivek. Thanks for having me. Definitely first Azure Happy Hour.
Yeah, so cool. So this will be my first Azure Happy Hour where I'll keep quiet, and I will definitely ask questions. Don't worry about it. But I'll keep quiet for some time so that we understand the complete practice. And then, as I told you, right, I have the pen and paper ready where I'm noting down all the things, what you're going to share with us, and obviously we will ask questions at the end. If something, if the community have some questions, please make sure you post it in the chat. I will pick all those questions and let Karan also answer those questions. It's all muted right now. We will unmute at the end of the session where you can unmute yourself and ask questions to Karan and myself as well. So cool. So Karan, I'll not waste much time. So I will hand it over to you.
Thanks a lot, Vivek. Thanks, Rashmita, for having me. So it's really great, to talk about this. This is one of my favorite topics. Let me start sharing my screen. All right. Okay. Is my screen visible? Oh,
yes.
Okay. I have to just try to. Okay. Great. So I don't have my chat open over here, but if something comes up, any questions in between, Vivek, feel free to just let me know in the chat. So, all right. Hello, everyone. And, of course, by now you know that we're going to be chatting about the DevOps practices at GitHub. So, but before that, a quick intro. I know Rashmita and Vivek also have mentioned, but I'm Karan, and I lead developer relations for GitHub in India. I work very closely with communities, and also very passionate and interested when it comes to cloud, DevOps, open source. And when I'm not working, I like to read a lot of books, and then just work on some of my acting, anchoring, and some of my filmmaking skills. Fun facts: I have a lot of other things in and around me that is useful for such things. It's gotten a lot of dust, but I actually do use a clapboard, which is there, and a whole lot of other things. So if you want to know more about it, happy to tell about those practices as well. But anyway, I know this is there's a lot when it comes to DevOps practices, and it's very difficult to kind of share or cover a lot of those things in just this one session. But I'm definitely going to touch upon a lot of key aspects of some of our practices here at GitHub. So let's start. One of the key things, of course, a discussion on around DevOps cannot really start, I would say, without like our key metrics itself, right? It's really, of course, most of the times when people think that it's all about just CI/CD or just the deployments or the pipelines, etc. Of course, they form a major part, but what does it really mean for developers? What does it really mean for customers? What does it really mean for the product itself, right? So there are a lot of things that DevOps as a practice will have an implication on. So there are really four key metrics that we really look at with a lot of our processes, which are essentially this. So we see the deploy frequency, how frequently is the team deploying, the lead time for changes, that is how long does it take to get code successfully running in production. And then the time to restore a service. So if there is an incident that happens, how long does it take to recover? And also the change fail rate, which is what percentage of changes to production result in a degraded service, right? So whatever process improvements or whatever some of the initiatives that we work on um, to grow the practice internally, we kind of try to align this to these four. I won't be talking about all of them right now, but we'll speak a little more around the first two, that is the deploy frequency and the lead time for changes. So one of the really big things I would say at GitHub as how GitHub is built and developed and deployed, we're super big when it comes to chat ops. So a whole lot of the things happens through chat ops itself in Slack rooms. Be it if you have to run a pipeline or kind of check the status of a pipeline or a whole lot of other things. I'm going to give you some more examples, but this is one of very, very central aspects to how many of all of us developers and engineers kind of work when it comes to the various different systems and the processes, etc. And the hero for this film, the hero for this movie, when it comes to chat ops, is our own Hubot. So you can go check it out on hubot.github.com. So it's a chat bot essentially that's open source and that was built by GitHub. And it's the reason why we don't call it as a chatbot is because Hubot really has a personality here at GitHub. It's not just a chatbot that's used for DevOps practices, but it has a personality. It can remember things, it can say funny things, etc. So there's been a lot of creative stuff that has gone into Hubot as well. So this is one of the central aspects, Hubot, which is kind of used to work around with chat ops and a whole lot of the other automations on issues or pull requests or actions or Slack rooms, etc. So Hubot is kind of like the main hero of this movie. So that's just a overview that I wanted to tell you because I'll show you some of the things later on as well when it comes to that. But there is one other thing that I want to talk about, which is which many of them might think that it is just related to software development, but actually plays a really big role when it comes to our DevOps practice as well, which is called as feature flags. So we use feature flags to really reduce the risk of deploying to production. So any potential risky change is put behind the feature flag in the code, and then when the deployment is done, we turn on and enable the feature flag to everyone or a certain group. So this way, what we are doing is we're minimizing the impact of the new changes, and if something goes wrong, we can disable the feature flag completely in a matter of seconds without interrupting other deployments. So if you were to think about how you might be doing this traditionally, right? I mean, if there were no feature flags, you might probably be deploying a branch or a pull request, etc. And if something goes wrong, you would have to revert that PR or roll back the deployment, right? That is, of course, still one of the things that we do, but feature flags helps us control a lot of these things through code itself rather than our deployment process. So our model when it comes to just some of the branching strategies that we use, and I'm talking about building GitHub itself, Some of the things that I'm talking about are across the team. Some of them have individual teams working in different way, but most of the practices I'm talking about are ones which are across all of the engineering teams at GitHub, and which are used for building github.com that you all of you see. So here's something that might or might not be surprising to many of you, but we don't use long-lived feature branches. Rather we use feature flags, like how I mentioned, to really develop on the feature. So what we actually do is we follow. I'm going to be talking about it later, but why this is helpful is that see, when we're using the feature flags, you can actually create these in small batches, and it's easier to kind of review by other engineers in pull request rather than like a long lived feature branch. And not using this actually avoids a lot of potential merge conflicts and clashes with other features under development or deployment. So if you have a long running feature branch, and then your main branch changes, there could be a lot of potential merge conflicts in the common code base and things like that, etc. Which is why we don't use long-lived feature branches but feature flags. And generally, of course, the smaller is the change in a patch, the lesser there is a chance to get something wrong during the production deployment, right? So we don't really use, like I mentioned, long-lived feature branches. One of the other things is that it's really helpful for us when it comes to testing these features itself. So in our dev environments, we can actually toggle these feature flags from the command line itself. Once our application is up and running, so we can disable, enable, etc., and test it out in the dev, and also in automated tests. During CI, etc., we can enable or disable these feature flags. In the code. So, for example, in our CI, we have kind of two different builds. One that runs with all the feature flags disabled by default, and if that particular test needs it, then it can enable it. And then one other build which runs with all feature flags enabled by default. So one build which will have all feature flags disabled, and one which is all enabled by default. So this really drastically reduces the chances of not covering most code paths in automated tests, right? Because you want a lot more code coverage, and doing largely these two strategies helps traverse most of those code paths. And
So
again, yeah,
there is a question in the chat.
yeah.
So how do you manage the lifetime of the branches?
Hmm. Right.
That's
So
the question.
right. See, like how I mentioned, there is no long-lived feature branches at all, right? So the way I'm going to be talking about, what is our branching model soon, but largely, branches are for anything that is, immediately deployable. It could be a full feature, it could not be a full feature, right? So it's a branch deploy model that we use. I'm going to be talking about it in a while right now.
Just trying to understand. So basically, you have a couple of features, and you
Hmm.
have enabled the features with flags.
Hmm.
So that means once you enable the flags, only few people get those features for various testing and other things, but few of them don't get it. And probably production, nobody will be using it. Only for few people it is enabled. But the question here is, if you found issue, you will not be using branch to fix the PR, but you will create a new PR for that,
Correct.
fixing that issue.
Exactly. Exactly.
Okay.
That's right. So there is no long-lived branch at all. So once there was a deployment with a bug fix or a feature, etc., and whatever is the associated branch with the PR has been merged, there will be a new PR to work on that. So that is why there are all of the multiple branches and the multiple PRs, and nothing which is long-lived.
Got it. So there are a couple of questions though. There is, yeah, I mean, from Saurav, what is your Git branching strategy? But again, you are anyways going to go in deep in that.
I'm gonna
So
talk about
anyways,
the
it's
branch
there.
model.
And there is a question from Balaji who is saying there is two branches. One is feature branch and the other is SLA branch for an application. Is it good practice to merge the code from feature branch to SLA branch? Is there any better way to do delivery from SLA branch? You mean to, I don't know, you know what is SLA branch? I've never used that before, but
I'm guessing, those are for, things like bug fixes or, hot fixes, etc. that impact SLA. But again,
okay.
you see, this is my take, Vivek, feel free to let you know yours. There is no right model when it comes to, Git branching. It is based, that is why it's a practice, it is based on what works for all of your team, and how it really helps your goals, right? So I'm going to talk about the branch model. I know that's something I'm going to be talking a lot more around deployments itself, where I'll talk about the branch models and everything else. But essentially, like how I said, there is no uh, right way or the wrong way. It depends on your use case, your practice.
Yep. Go ahead, Karan. I think we'll take questions
Yeah.
later as well.
So one of the other things, just as a small clarification, Vivek, to your previous overview. So the feature flags, can be enabled or disabled, which we usually do even in production, through a query string or something else within a request. So I'll talk a little bit about this, which is we have different shipping strategies itself. How we kind of use feature flags. So there are multiple mechanisms for this. The first, of course, is individual actors. So we use this mechanism to feature flag employees working on a feature, or to enable the flag to customers that are experimenting with a feature, or if they have a problem we are trying to fix, etc. So you can actually go add the individual handles, etc., for the feature flag to be enabled. The second thing that we also use is something called staff shipping. So when a feature is almost ready to be released, think of it almost like an alpha. We first enable it for all GitHub staff, and we kind of publish an internal post as well for awareness that hey, this feature has been staff shipped, and also create an internal issue for gathering feedback or possible bugs, etc. So this is so the alpha per se, which we call as staff shipping, is done through feature flags. And then again, we of course use it for when we're about to release an important feature that will say impact workflows of open source software, etc. We gather feedback from the maintainers or other types of users. We test the feature with a small group first, and after some time we'll interview, gather some more feedback, etc., and validate it. So feature flags is used to enable features for some of these people as well. And I think I mentioned earlier as well, but you do it for a percentage of actors as well. So we can specify a percentage of actors for which to enable the feature flag. And in this case, when an actor is flagged, it remains flagged. That actor remains flagged unless the feature flag is rolled back. So and of course we have some of the other automations also related to this. For example, when a percentage of actors for whom a feature flag is enabled changes, there are notification, etc., to the relevant teams who know that okay, this is in larger use, etc. This is actors, but we do dark shipping as well. So dark shipping is enables us to enable a feature flag for a percentage of the calls. So it's not related to actors. It could be the same actors or different actors, but it's a percentage of calls. So one actor, if Vivek is using it, he could be enabled the feature flag for one call, one request, and other one he could not be. And this is not really meant for features that are visible to users, because then you'll have a very different user experience. You'll get confused once, say for example, this button is there, once it's not there, etc. But this is more for say internal changes, say something related to performance improvement or a query or something like that. So to kind of test out some of those things, we do dark shipping. So that's about feature flags, and that's it's really interesting. I know a lot of organizations also use feature flags very largely for very similar use cases. Of course, there are a lot of other considerations. Every feature flag, has a cost associated with it, because you're essentially, when you have a feature flag, uh, when there is a request that comes for that feature, also you have to keep checking whether this feature is enabled for this actor or not, etc. So there is a cost, and there is also, a lot of maintenance sometimes that's required. For example, when a feature has been rolled out to 100% of the actors gradually, it doesn't make sense to have that feature flag code internal. So we have automated some parts of that as well, wherein once a feature flag has been completely enabled, there will be a kind of a linting job that happens within the code, and does some modifications, if possible, remove some of those feature flag code to make sure that it doesn't form a technical debt, it doesn't form a performance debt, moving forward. So that's one aspect, which I wanted to talk about, the feature flags. So the second thing that I want to talk about is our CI. Okay, so there is one unique thing. I'm not going to talk about like our entire CI process. There are multiple stages to it, but there is one very interesting optimization or improvement that we did with when within our CI itself, which is what I want to talk about. So one of the problems that we faced, and how we kind of worked around it, right? So just looking at going back to that slide when I first spoke about, right, the deploy frequency, and I spoke about the lead time to changes, right? So CI, of course, forms a main part of what affects our lead time to changes from code to production. So this is how our CI used to look before. We identified that engineers waited an average of 45 minutes for a successful run of our CI suite to complete before merging any change. And this 45-minute lead time was repeated once more before deploying a merge branch. So if you look at it in a perfect scenario, a developer waited almost 2 hours before checking in code before the change went live on github.com. That's a lot if you think about it for a lot of the deployments that we keep doing. So our deploy frequency is actually really high. There are multiple deployments that keep happening every hour throughout the day, etc. So if you think about such a large velocity and deploy frequency, 2 hours is a really long while for someone to wait. So we did a few things actually. One key thing actually that brought down this 45 minutes to 15 minutes. So it was one key thing that we identified and fixed that, or rather addressed it. So before that, let me give you an overview of what's behind github.com. This will be, I think, interesting for many of you. So github.com is a Ruby monolith. So it's it's one repo. I'm going to be talking about it a little more, but essentially there are 7,000 test suites, around 5,000 test files, and on every commit there are 25 CI jobs that run on every commit. Yeah, so of course engineers have to be careful about not just going and then pushing every commit every time, because that's gonna kick off multiple CI runs for every commit. But what I want to call out is within this 25 CI jobs, 15 of those CI jobs should complete before merging a pull request. So this happens on a PR. So this meant that if you look at it, a engineer at GitHub spent approximately 45 minutes and 600 cores of computing resource for every commit. So that's a lot of developer hours and machine hours that could be spent creating more value for our customers, right? So then we started seeing into, okay, how can we really optimize this? That 45 minutes to 15 minutes kind of a thing, right? One of the main things, if you're already aware, is that github.com is one part of GitHub. There is also something called as GitHub Enterprise Server. So this is the on-premise offering of GitHub used by our enterprise customers, etc. So for GitHub Enterprise, server, we ship a new patch release every 2 weeks and a major release every quarter. So there were two long-running, test suites that were added to the CI workflow to ensure that a pull request did not break the GitHub experience for enterprise server customers. Because this is on-prem, right? So it was also clear that these 45-minute test suites did not really provide any additional value, and it was blocking the GitHub.com, the main cloud deployments itself that happened continuously throughout the day, right? So driven by really this, customer obsession and also satisfaction of engineers working at GitHub, we developed something called as a deferred compliance, right? So it's both a concept as well as a tool that we use internally. So what this is this tool integrated. It's of course an internally built tool. It integrated with our CI workflow system and aims to strike a balance between improving our lead time for change in deploying GitHub.com, the one that all of you use, and also creating accountability for the quality of the enterprise server on-prem, right? So if you look at it, the long-running CI jobs are really no longer required to pass before a pull request is merged, but the deferred compliance tool is monitoring for any test failure, right? So if the long-running, so let me show you through a diagram that I have. So this is how it looks like, so developer creates a pull request to merge a change. And if the required CI jobs all succeed, the pull request gets merged and deployed, right? But and at the same time, the long running non-required CI jobs also keep running. And once the pull request gets merged and deployed, if the long running CI jobs also succeed, then well and good, that's fine, right? But if not, if it doesn't, if it fails, then there is an issue that gets created within the monoliths, and we kind of tag it appropriately called deferred compliance, etc. And from then there is a timer that gets started for 72 hours. Okay, so once that issue gets created, there are people who are tagged, the author of the commit, the author of the PR, etc., who get tagged saying that, hey, this long-running CI suite is broken. And then, within those 72 hours, the engineer responsible for it can fix the broken test. And after that, if the long-running CI job succeeds, that issue is closed out. If not, if that 72 hours, is over and that issue has not been fixed, or if it's still failing, etc., there is one other compliance issue that gets triggered. And basically what happens is at that point in time, everything is blocked until it's fixed, right? So all deployments, are blocked and halted unless there's like a really exceptional situation. So this actually creates, helps us in multiple ways. One is it helps reduce our lead time to change to deploy to GitHub.com, making the CI faster. But at the same time, it helps create, accountability for, the on-prem deployments as well, so that it works flawlessly on GitHub.com as well as, on-prem. So this 72-hour timer, is actually customizable, but internally, our analysis showed that with a global team of, engineers, right from all the way from the West Coast in the, US, all the way to Australia, etc. So the 72 hours actually helps reduce the possibility that, change merged by a developer in San Francisco on a Friday afternoon, say, did not unintentionally block the deployments for someone in Sydney on a Monday morning. So this concept can be used for any long running CI that does not need to block deployments while at the same time creating a call for action for CI run failures. So this is one of the really key things that help bring down the lead time for change by reducing the time taken to finish our CI jobs. So I want to take a pause here before I head to the next big part around deployments, a very, very interesting part, and see if there are any questions.
Yeah, there is one question. Is there
Yeah.
any documentation related to deferred compliance?
Not really. I mean, I don't know if you're asking external documentation. No external documentation, per se. But internally, of course, we document this a lot. Nothing externally, like how I said, this is a concept, of how you can address some of the things to bring the lead time to change down. There could be other strategies that you have, right? But if you look at it, one of the key parts was that we began with the intent of reducing this time of saving developer hours, saving machine hours, analyzing, what's really happening with all of the CI jobs, and fixing it in a way that meant that our specific metrics were also achieved, and whatever is the mission that we had in mind for this. Right? So it's that's one of the key things that you need to really think about, rather than is it defined compliance, or what exactly it is. For us, again, it's that the the whatever is the PR should comply and should be safe enough to deploy on-prem, on an enterprise server, right? So we kind of deferred that to ensure something else is non-blocking. There could be other strategies that might work for you, but just a concept.
Yeah, after saying this, I'm just going back 5 years, like how when we used to do all these kind of process. In while I was in DevOps head, we were looking at all these kind of processes and trying to build our own process, making sure we do reviews and improvise all the CI and all the stuff. Amazing. So there is a question, I'm not sure. What testing tools do you use? Couple of like somebody suggesting, is it Sonar Cube or something? I think Sonar Cube is more of Java, but yeah, would you have any specific tools for testing?
It's multiple, because there are a lot of different microservices running various different languages and frameworks, etc. Um, excuse me, but for the Ruby monolith itself, there are the regular Ruby ones. There are, of course, unit tests and everything else that's done using some of the Ruby constructs itself. And then there is also some of the integration tests that's happened. So there's a whole slew of tools that are that are used. So it's not really like one thing, because the GitHub.com might be a monolith, but there are definitely a whole lot of microservices powering that.
And there is one more question on what all things CI in CI pipeline, what all things you check. I mean, obviously it's again, as you told, there are so many scripts.
Yeah. So
which
see,
will
I
run.
mean, if you look at it, it's of course like key categories. There are unit tests. There are linting that happens. There is all of the integration tests, and then there is like the builds and deployments. So these are kind of like, of course, the four main categories that are there. But each of the jobs, each of the 25 plus jobs, really look at say linting for that specific part, and performance. Also, there are performance checks that happen, whether what code that you're introducing, does it create a performance issue and things like that. So a whole lot of different checks and tests that happen.
Yeah. And again, there is a question on the review process for the feature.
Oh, great. I love that. So good question. So see, one of we use code owners a lot, very heavily. So in case you haven't seen it, go check out code owners on GitHub. So basically, code owners is a file that you have within your repo, that defines who is a code owner for a specific file, or for specific different things. You can have like regex in it, etc., and all of those things, right? So we use code owners a lot for reviews. So what this really does and helps us is that when someone creates a pull request against any file, it could be even in a feature that they are not working on, it automatically requests approvals for the PR from the people that's defined within the code owner. So this could be anyone, and this could usually be various people. Each team have their own way of defining who the code owner could be. Sometimes it could be your peers, it could be someone else, etc. as well, right? So it's not, there's no kind of like a golden rule that this is who a code owner or an approver must be, etc. But that is one of the key things. All the approvals are really driven by code owners. So once when someone creates a pull request, um, they don't really have to worry about like who am I supposed to ask for approval for this, etc., because the automation itself will start kicking in and request approvals from the relevant folks.
But there is a follow-up question. How much time does review takes? That's a good question, actually.
So, largely a lot of the there are two parts to it. Okay, let me address this before going on to deployment part, right? So, see, once when a pull request is created, it depends again on the specific team and the specific feature. Some of the teams have something called as an FR, it is a first responder. So what the first responder usually does is, as soon as a pull request comes for that team or for them, etc., they quickly take a look at what that pull request is and almost in a way triage it. Does this need some more digging into to see what this code is doing, etc., and kind of take a look at it. If it's just a simple change, etc., they go ahead and resolve it and approve it, etc. If it's going to take more time, then probably more people might come in, take a look, offer some suggestions, do a little back and forth, etc. But ideally, or for a lot of the deployments, this review happens in less than 24 hours, so that someone comes and takes a look. A lot of the deployments that I've worked on has deployment, and entire deployment itself has happened in less than a day, including the approval and staging and testing and complete production deployment, etc. So it happens really fast, because that's one of the key aspect that defines our deploy frequency as well. We want to have engineers deploy as frequently as possible, and there are multiple deployments that keep happening. Right now, if I go take a look, there'll be a lot of deployments happening like right now as well. So the deploy frequency is very high. So the review time is adjusted accordingly.
Yep. I think
anything?
we can continue.
Okay, great.
And then we'll take questions at the end as well.
All right. So talking about deployments, this is a very, very interesting part. How we actually get the code to production. How do we deploy it? So I spoke a little about the development part and the feature flags, a little bit about our CI part, but let me talk about our deployments itself. So we use what we call as a branch deploy model. So we actually deploy branches before merging them into main branch. So this actually means that developers can actually add changes to a queue, check the status of a queue, organize groups of pull requests to be deployed and merged, etc. I'll give you an overview of what this really looks like. So of course, main branch is one which is which has to be stable and deployable always, right? I know there were questions previously as well in terms of the branching model, etc. So this is pretty much like the golden rule when it comes to the branches, that main branch, whatever is in main branch, should always be stable and deployable, right? But what we do is that if you look at generally how someone goes about deploying, so they create a new branch, right? It could be a branch, say, if you're working on something around repositories, it could be like MV current hyphen repo hyphen fakes or something like that, right? So some of the teams, of course, follow certain naming conventions, etc. They create the branch, start working on it, all right? And when they are ready, probably have a draft pull request already, ready, or else go ahead and create a pull request to merge everything in that branch into the main. That is when all of the reviews and everything else starts kicking off on the pull request. The CI kicks off and all of those things happen. And once the CI is complete, the approvals are complete, and all of those things, we do a staging deploy. If necessary, it's not really required. You can do like a staging deploy of that specific branch. You're not yet. So even though the pull request has been approved and the CI is green, we don't merge that in until it has been deployed. All right. So one of the CI jobs actually checks whether this has been deployed or not. So once this branch has been, say, deployed into staging, and the developer has been able to take a look and see and test everything is fine, etc., then this branch can be deployed into production. I'm going to come a little bit in a few minutes on what that really means, how that deployment happens. But once it has been deployed into production, the pull request gets ready to merge. So for this, again, we use the environments feature within GitHub itself. So environments, really help configure, whole lot of things around secrets and everything else, etc. So once a branch has been deployed successfully to production, the pull request can be merged into main. So that's the only part. There is one other way how we kind of improve deploy frequency, where we batch all of these pull requests. But I'm going to talk about it in a little more while, if you're interested to know about it. But coming back to the deployment part, a key thing that I spoke about is all of this happens, using chat ops in a Slack room. We have called as a .com ops, and I want to give a little bit history to this as well. So this is a very simple, system where someone can go and then do a deploy of a branch, etc. But it started causing a lot of confusion while monitoring a deploy, in a single chat room, and manage the queue and everything else as well, because there were a whole lot of engineers who were trying to deploy, and all of a sudden this channel became, which was once like a central and a crucial part, it was overwhelmed by the amount of information, etc. So engineers could never really track the change through the system, which resulted in a reduced capacity for a developer to deploy, and also increase the risk profile. So as an example, this is what it really used to look like. So user goes, does a .deploy slash GitHub slash a one of the branch, and does a deploy, right? And then Hubot, like how I mentioned, comes over and then says that, okay, manual deploy has been attached to Canary, and then this will proceed once the deploy is confirmed. So it will give all the relevant information for the developer to know about, right? So this is just one step of almost like a dozen spread across hundreds of messages, and hard to keep track and validate really the state of a deploy itself. So that's where we introduced a system which is, we developed it almost like a state machine in terms of how deploys really proceed. So I want to show you again one other diagram that explains this, right? So so this is how the state machine really looks like for deployment. So so it shows that there is of course a pointer that we start, where we start with a deploy to 2% Canary, okay, and there is an automated timer gate of 5 minutes between every stages, so that once that deployment is complete, a developer can go and then check if everything is still fine, go look at a deployment confidence dashboard, look at Sentry to see if there are any issues that are coming up, etc. And at that point, if the 5 minutes is over, a developer can go ahead and pause the timer and get some more time to test out, or they can even proceed and say that, okay, I'm done. So once that's
So
done,
yeah,
can I just complete this?
yeah.
Yeah. So once that's done, the deployment after the automated timer gate proceeds, it moves over to a 20% canary and then, deploy to production. And then when I said, that's when once it's deployed to production, it's when, you go ahead and merge it into the main branch.
Yeah, so there's a question, very important question. Somebody is asking is what is Canary deployment? So it is very important now
Go
to
ahead,
just
Vivek.
talk about.
This is bread and butter.
No, no, you go ahead. So I'll let you answer this one. So go ahead, Karan.
Oh, Vivek, you should go ahead and explain that.
So you can see that, right? So basically, there is a deployment which is happening at a very small state, right? So basically, you're deploying on a couple of maybe this is Kubernetes or something which you're deploying on. Only a couple of
Yes.
containers are getting deployed onto the latest version of the code, and it slowly increases from 2% of the containers which is running on the specific production environment, and probably it goes on to deploy to the next 20% and goes on to production. Is that correct?
Yeah. So see, there are various different deployment strategies, right? So when you're deploying, you can do, say for example, something as like a red green or a blue green deploy, etc. Where once when you're deploying, deploy an entire cluster or an entire server, and bring down the other one, or kind of roll it out slowly in stages when it is on a cluster, etc. Right? So this is more to do with, like, when you're deploying, when you're pushing out a new image or a new container. How do you do it when you have say a large cluster, or in this case when we're deploying into a Kubernetes cluster at GitHub, right? So it's which all clusters will it be deployed into, or how many pods or nodes or deployments will it be deployed into, etc. So it's kind of exposing your deployment in small stages rather than all at once, and at the same time reducing the downtime that might be there during the deployment as well, right? So there are of course a whole lot of things around the strategy itself, like you can think of it like, hey, like if I've deployed to 20% canary, will it mean that some people will see something different, some people will see something else, etc. Of course all of those things are there, which is why the timer gates come in, so that people are not exposed, or users are not exposed to very differences for a very long time, right? So it's a strategy, it's a deployment strategy. And what we use, of course, here is Canary. Anything else, Vivek?
There is one question on unused branches. Basically, do you automatically archive them for 90 days and delete them for 30 days?
Not really. Those branches, are deleted as soon as the PR is merged. You can always go back and then restore it, but since it happens through a PR, you can always go back, do like a git blame to see what was the commit that introduced it, what was the PR that introduced it, etc. So the branches, to keep all of it clean, is deleted.
I think you can go ahead. I don't think so.
Okay.
Any more questions yet?
So this is, an example of what it really, really looks like. So we created an entire UI component that helped us operate the state machine, and this was combined with the traditional chat ops as well, which developers were already familiar with. So you can see an overview of all of the deploys as an example that have been deployed to github.com, and then rather than tracking down all of the various messages in a Slack channel, you can actually go to this consolidated UI. You can see the state machine progression as well outside on the right, where it's like preparing a deployment, deploy to Canary, a timer gate, change the percentage to 20%, and then like deploy to production, a timer gate, and then after that move over and merge the branch, right? So this is how it kind of really look like of our UI, excuse me, for a production rollout pipeline. And if you look at a very specific deployment, deployment, you can see that's how it would look like in our UI, where you can see everything that has happened right from when the pipeline was initiated, until it is merged. You can see the different stages, the timer gates, which which has gotten elapsed, etc., how long it took, and all of those things. And in case we have to revert back, on the top right we have like the lock button, so you can lock the deployment as well, or you can roll back and revert the changes, etc. So that's also possible through the UI itself that we've done. So all in all, the deployment really through chat ops combined looks something very similar to this, right? So we do like a pipeline deploy, specify what is the branch, and Ubot, our chat ops, will kick off a pipeline run, and will start progressively deploying. So if you're there in the .com ops room, any developer, they can see these messages that okay, there is a timer gate that's got completed and it's progressing, timer gate that's got completed, that's progressing. But at the same time, you can just have your UI component, the UI part of the pipelines open, and then see how all of it is proceeding. So that's a very high level overview on how we kind of deploy at GitHub. And I'll come to the last part that I have right now. Again, very interesting part, and then we can just open up to all of the questions. It is Codespaces. So the way that we use Codespaces, and it was honestly like a problem that we had at GitHub itself, which was solved using Codespaces, right? So by the way, if you aren't aware of Codespaces, it is a GitHub product called GitHub Codespaces. You can go check it out later. So, but essentially, GitHub is currently right now being built using GitHub Codespaces, right? So an interesting fact is that the code base is actually 14 years old, and the first commit was, when the first commit was pushed, Rails was just 2 years old, right? So it was very new when it started, and most of the developers were building on testing on Mac OS. That's where most of the commits were coming from, and there are millions of commits that form a part of the code base, right? So when a developer had to really go do something on the monolith, right? So we have a paradigm called as scripts to rule them all. So basically, I think I do have, yeah. So it looks like you do a git clone, and then we have a script called as bootstrap within a scripts folder, a script called as setup, and a script called as server, right? So this is a very standard mechanism that we use, not just for the main GitHub repo, but also for a lot of our other repos. It could be for microservices, or a whole lot of other things that could be internal tools, etc. So everyone knows that if there is a script folder called bootstrap, that's all you have to do to pull in all of the dependencies or anything else. If there is a script/setup, that okay, you have to run script/setup to do any of the post installation stuff that needs to happen, and the script/server to actually bring up the server, right? So everyone knew about it. But this process really took half a day's time, for any developer or an engineer, right? And while running any of this, if there was an issue, it used to open up a new issue, and if there was a issue with a small I, it used to open a new issue with a capital I on GitHub, and an internal support team used to help this out. This is this took a really long, while I remember when I first did it, I was just waiting. The git clone alone itself takes more than like 20 minutes or 30 minutes, etc. And after that, it takes a super long, while. And if something went wrong in between in script/setup or script/bootstrap, we also had like a really fail-safe command line argument for all of these called as nuke from orbit, so it wipes out the complete, state, whatever was there, and starts all afresh, so you can think of it of how long it would take, it used to take for a really long while. And also, like how I mentioned, the clone itself used to take a long while, because the GitHub monolith, is 13 GB on disk, right? So it takes like how I mentioned, 20 to 30 minutes for cloning itself, and for a whole lot of the other things like for bootstrapping, it used to take like again another 45 minutes for all the bootstrapping to run, right? So that's where actually GitHub Codespaces, which was a product that while being developed we were using it itself and were improving it for everyone else as well. So I want to give a little bit overview, quickly about Codespaces before I go into, see how this, really helped us. So GitHub Codespaces is a development environment in the cloud that's, that's backed by virtual machines, right? So you can start from a repository or pretty much anywhere and create a new code space that spins up a virtual machine, brings up an IDE like VS Code, connects to your repository, and then you can start working it and developing it right on the cloud without actually doing all of the git clone and then running the bootstrap and everything else. You can even use something called as a .dev container JSON files, which is a part of VS Code. You can use those to configure a lot of the lifecycle hooks as well to make sure that once when a Codespaces environment is up and ready and running, all of your application is actually ready to, it's been bootstrapped, setup and dependencies have been done and a whole lot of things are ready, right? So, but of course, the main part is that a Git clone actually runs within this virtual machine, right? Because the repository is there, a virtual machine is there, somewhere you have to do a Git clone, right? So as an overview, this is how it really looks like. So when a user creates a code space, the GitHub repo gets cloned into the virtual machine. So a VM gets created. And within that is where a clone of this GitHub repo is done. And then there is a container that runs VS Code and pretty much everything else that gets attached to the repo within a VM. And the user actually accesses the container, not the underlying virtual machine. So what we did was, and this is true even in GitHub Codespaces, even though you can define it, is that we used a shallow clone, not a full clone, right? So think of it as a Git clone with a depth of 0. So only the tips of everything was actually cloned when a code space gets created, right? So this 20 minutes of cloning time that would have otherwise taken a really long while came down to just 90 seconds, So right away over there, we saved, 18 and a half minutes just by doing a git shallow clone, because most often you want to work on the tip, of the branch itself, right? Rather than some of the other commits. You can still do, like a git clone with other depths as well, but this was one of the things that was a part of, code spaces, right? And of course, we use containers as well, which used to get built every time a code space was created, right? So, which basically meant that you once the clone has been done, you run the bootstrap, you run the setup and everything else, and that is the container that used to come up, right? And that, of course, was not optimal enough of, whenever you create a code space, a new, an entire 13 GB or, sorry, the whatever it was a shallow clone, the whole container gets built. So that's where, again, we use super heavily internally to build GitHub itself, is where GitHub Actions came in. So there's a GitHub action that which we have, which runs a nightly to build and push a Docker image with all of the dependencies, so that once when you create a code space, any developer creates a code space, there is an already available image. It doesn't build on demand, and also it creates a shallow clone. So this actually brought down our 45 minutes to just 5 minutes, all of these optimizations with code spaces. Now, of course, the team was really, really ambitious and said, let's actually bring it down to 10 seconds. And this again is something that has been very much possible because of something called as pre-builds, right? So what a pre-builds is, they are pools of code spaces that are fully cloned, bootstrapped, ready. All of the built images are there, etc. Um, which when someone creates a code space, there is already a cloned image that would be ready. It would have been bootstrapped and everything is ready. So you can just bring it up, which will just take, a really, really short while. And these code spaces that, we run to develop github.com are super powerful, right? So it's a memory with 64 GB, etc., and super powerful ones. And the best thing is that we can just change how much the resource consumption of this code space is, just by defining it within the config file. So this actually did bring down, the time to 10 seconds, right? So right now, if I had to, do a bug fix or something else within GitHub, and I create a new code space, it will be up and running and ready for me with 10 seconds. I still remember the first time when this was introduced across all of GitHub. I was like, phew, thank God, no more, half a day time of clothing and bootstrapping and setup and everything else. I just go create a code space. VS Code is up and running. I attach it to my, local code space, local VS Code instance, and continue whatever, I have to do. So I think we are a little bit and well over time, but those are some of the key things that I really wanted to share. Like how I said, these are a whole lot. There are a whole lot of practices, of how we accomplish various stages and life cycle of DevOps itself. But I wanted to give you a glimpse of some of the things that we do. So yeah, happy to take up any questions. Have a chat on anything else right now.
Yeah, there are a couple of questions actually. So let me start with one question we missed. Um, do GitHub use Git flow branching strategy at GitHub? I think it means like workflow strategy.
Yeah. So the GitHub flow strategy, yes, it's of course the same one, with the only difference which I mentioned is that um, well, actually, it is the same. Yes, we use the same GitHub flow itself because we deploy the branch first and then merge it into main, which is what is the GitHub flow. So yes, that's the exact same flow that we use.
And there is one question on, can you share the community name for the Slack? I think it is .com ops, right?
No,
Like,
that
it's
is
not
that
a
is just
community, it's the
it's
internal
an
one.
internal channel. It's a Slack room. Yeah.
Yeah,
So it's
yeah.
a Slack room for all of the ops. That's all.
That's a internal to
Yeah.
GitHub team.
Internal
So
to
yeah,
GitHub.
yeah.
There are
And
a lot of such ops channels that are there, which are run by Hubot. Deployment is one of the things. That's all.
so there's a question on like code spaces incur additional cost for enterprise. Does it
Sorry,
cost
I
for the
didn't get.
enterprise? Code spaces incur additional cost to enterprises. I think we lost Karan. Let's give it.
Sorry,
Okay.
I got disconnected. Yeah.
So the question is, will code space incur additional cost to enterprise?
Yes. So Codespaces comes with a pricing that that is there, which you can go check out within the GitHub website or the GitHub docs, etc.
So from a code space perspective, I can add any of the environment. Is it just like my GitHub actions, like where the way the runners are there, right? Can I attach any environment to that as well?
Not really.
No,
That's
I
something
should
that
not.
is, yes, that is something that is configured and hosted by GitHub itself. So you can configure the container that's gonna run when a code space comes up, but that's about it.
Okay. Okay. Any, I think we have opened the, uh, your mics are enabled. So if you have any questions, you can unmute and ask questions. Anyone has more questions or, but it's just to recap, a couple of things to, just to take away for me is amazing Hugo bot uh, for the chat ops and
Yes, it's
and
open
I
source.
like, yeah, I like the deferred compliance. There will be some issues or the other, and that's a nice way to handle that. It's a nice strategy. It's a good takeaway if you are looking at solving such similar kind of a problem. It's an amazing takeaway there. And obviously the Canary deployment. So a couple of things which is very important from a deployment perspective, and how do you manage those deployments, and also the code spaces, how you use code spaces, because I've used code spaces, but I was not sure like it's solved such a big problem, like 20 minutes to 10 seconds. It's
45 minutes
basically
to 10 seconds.
yeah. Uh, and what I like here is how GitHub is using their own product and going into their own problems and building the product best for the customers, right? So that's the most important thing here, right? To take away, like they're using their product and they are facing issues within their product, and they're building tools for that product and making sure that community gets that product as well. So that's the amazing crux here, right? So that's really nice to see. And there is a question as well, Karan. So can we use Codespace as CD environment, uh, GitHub Actions,
Sorry, GitHub Actions or code spaces?
Codespaces?
Not really. You can't use it for CD. Um, yeah, I mean, probably I don't know what might be the use case that you might have, but yeah, so I just want to share an interesting anecdote when it comes to code spaces itself. So we have within GitHub something called as review lab. So what this review lab is essentially a customized staging environment. You can think of it, right? So there is no one single staging environment. I mean, there is, but most of the times when you have to test some of the changes individually, developers can actually spin up a complete instance of github.com that's running on a server with their specific branch that's deployed, right? And most often, if there are small changes and things like that, etc., you can just run it within a code space itself, because it's backing it is just, we use like a 64 gig RAM and a lot more cores machine that we can just bring up the whole GitHub instance within the within that code space itself and quickly test it out. So that's one of the advantages as well, because you can say you're working on a web application, right? So you can run the server of the web application within the code space itself, and once the ports gets exposed, you can make those ports public or private within an organization and share it with others. You can almost use it like a staging environment for a short period, and then get feedback and work developing within that itself. It's a very, very interesting use case of code spaces.
You have any more questions? Let's give it a minute. While we are waiting for questions to come in, there is a survey link as well. Just key in your event ID. That's the event ID which is there. Just go to that link and let us know how this event was. And that's some we will we just with the feedback and also let us know what other sessions you want, so that we can definitely get this enabled. Yes, thank you for the so much, Karan, for the great session. That's the message in the chat.
Oh, okay.
So we'll wait for we can wait for 2 more minutes and see if there are any more questions. Else you know where to reach out to Karan. It's on his Twitter. You can maybe Karan, you can just post your Twitter handle there, so people can reach out to you if they have any specific questions. Uh, this is just a amazing walkthrough for me as well. So this it's just like as I told you, right? I went back 5 years back, and I'm just thinking how we did things in DevOps, and probably these tools were not there at that time. And I see that GitHub Actions were not there. There were there are code spaces were not there. So I am just wondering, how did we do DevOps? Like, yeah, yeah, that's cool.
For some reason, my message chat is not going with my Twitter link. So if anyone can drop it in there, that'll be great.
Oh yeah, I think I'll.
Let me share. It's handy with me.
So that's that. Vivek, what you said was interesting because uh, GitHub, we use GitHub itself very extensively to build GitHub itself. You name any GitHub feature out over there, we are using it to build that and the other features. Issues, pull requests, actions, environments, code spaces, a whole lot of things. The secret store itself and code QL, code scanning, Dependabot, all of those things we're using internally to build GitHub itself.
True. I mean that's the interesting point here, right? So that's how companies build developer products, right? They internally use it and they find issues, they solve that problem. Hey, we have solved this problem. Why not make sure that community also gets it? That's the point here. So cool. Thanks, Karan, for being here. It's amazing to have you here, and thanks for sharing those insights. These are great insights. In fact, I am sure people who watch this on demand will definitely love it, and they'll keep coming back for this because there's so many things which was discussed here. And thanks for being here. Thank you very much. Thanks, Rashmita, for hosting us as well.
So yeah, thanks a lot, Vivek, for having me. Thanks all of you for attending or watching this. And thanks Rashmita for hosting all of us over here. So it's been great. Let's stay connected.
Sure. Thank you so much, Vivek and Karan, for such an amazing session. And thank you all for joining us today. Please feel free to share your feedback about today's session. Also, please feel free to use the Learn module link, which is already displayed on the screen. Also, I've shared in the chat section. This will give you access to additional resources to take your learning further. Also, please visit our Microsoft Reactor Bengaluru meetup page for more upcoming sessions. Thank you all once again and enjoy the rest of your day. Happy weekend.